If a star exploded right next to you, you would not hear a thing. A supernova is the most violent event in the universe. In a single moment, it releases more energy than the sun will put out in its entire 10 billion year life. It can incinerate whole solar systems, and if one detonated close enough to fill your entire sky with light, it would happen in total, perfect silence. Not a whisper, not a rumble, nothing. Most people assume that it is because space is empty, and empty means quiet. That's only half the story, and it is the boring half. Here's the part that should unsettle you. Space is not silent at all. It's roaring. The sun, the planets, dying stars, colliding black holes, all of them are screaming out signals every second of every day. The universe is deafeningly loud. We're simply deaf to it. And to show you just how loud, consider the sun. The sun is pouring out a constant electromagnetic roar so powerful that if your body could register it the way it registers a sound, it would be like standing in the front row of a rock concert. Except the speakers are 93 million miles away. That's the thing we casually call a calm, quiet day. And the sun is just the local source. The whole galaxy is crackling. Dying stars, spinning neutron stars, the superheated gas swirling around black holes. All of them are broadcasting signals across the void without pause. If you could retune your senses to pick it up, the night sky would not be a peaceful blanket of quiet lights. It would be the loudest room you have ever stood in. So if the universe is this loud, why does space feel like the quietest place imaginable? To answer that, you have to understand what sound actually is and why it dies the instant it leaves home. Think of sound as a row of dominoes. When you speak, your voice does not actually fly across the room. What happens is that your vocal cords shove the air molecules right in front of your mouth. Those molecules slam into the molecules next to them, which slam into the next ones, and the next. A chain of tiny collisions racing outward until the very last domino in the line nudges your eardrum. That's all sound is. It's a pattern of collisions passed from one piece of matter to the next. The dominoes are the air. Now, take away the dominoes. On Earth, the air around you holds something like 10 billion molecules in every cubic centimeter, packed tight enough to pass the chain along instantly. In deep space, that same cubic centimeter might hold a single atom, sometimes less. The dominoes are not just spread out, they are kilometers apart. There's nothing to knock into anything else. And here's a detail that surprises people. Space is not a perfect total emptiness. There are a few stray atoms of gas drifting out there, a thin haze of particles between the worlds. So technically, a sound could exist. But the particles are so unimaginably far apart that any sound made from them would have a wavelength stretching for thousands of miles, and a pitch so impossibly low that no ear, no microphone, nothing we have ever built could register it as sound. The dominoes exist, they're just too scattered to ever finish the chain. So here is the key thing most people get slightly wrong. They picture sound as something that tries to cross space and fails, like a swimmer running out of breath halfway. That's not what happens. The truth is stranger. In a vacuum, the sound never even begins. There is no first domino to push. Your scream does not travel a short distance and fade. It cannot form in the first place because sound is not a thing that moves through matter. Sound is matter moving. No matter, no sound, ever. This is why the old movie line, "In space, no one can hear you scream," is not poetry. It's just physics. You could press a ringing alarm bell against the outside of a spacecraft, watch the hammer hit it, see it vibrate, and hear absolutely nothing, because the vibration has nothing to crawl through to reach you. But this raises a problem that should be bugging you by now. If nothing can cross the empty vacuum, then how does anything reach us out here at all? Stop for a second, because there is a contradiction sitting right in front of us. If nothing can travel through the vacuum, then the sun's heat should never reach us. The light from the stars should never arrive. We should be sitting in a cold, black, dead void. But we're not. The sun warms your skin. Starlight fills the night. Something is clearly making it across all that emptiness. So which is it? How can space block a scream completely, but lets sunlight pour through as if the vacuum were not even there. The answer reveals that we live inside a kind of a physical trap because there is an entire category of waves that do not need dominoes at all, and one of them is so strange it can grab the empty vacuum itself and ring it like a guitar string. Once you see how it works, that comfortable silence above you falls apart completely. Here is the resolution. Some waves need matter to move through, some do not, and that single difference splits the universe in two. Sound, as we said, needs the dominoes, but light and radio and all the rest of what we call electromagnetic waves work nothing like that. They are not collisions passed between particles, they are self-carrying. A better picture is a laser beam fired through total darkness. It does not lean on anything. It does not need a crowd of molecules to hand it along. It generates its own way forward, an electric field creating a magnetic field, creating an electric field, leapfrogging through pure nothingness at the fastest speed the universe allows. That is why the sun's light and heat sail across 93 million miles of dead vacuum and still lands on your face. Sound needs a floor to walk on. Light builds its own road as it goes. And once you understand that, the universe stops being quiet and starts being loud, because almost everything out there is blasting these self-carrying waves in every direction. The sun, the planets, the gas between the stars, all of it pouring out radio waves and other signals around the clock. Our radio telescopes are, in a very real sense, giant ears pointed at that roar. We've just been deaf to it without the right equipment. But there is one kind of wave that goes further than all of them, and it is so strange it sounds invented. We call them gravitational waves. To understand what they do, you have to drop one comforting assumption: that space is just an empty stage where things happen. It's not. Space is a fabric. It can stretch, it can bend, and it can shake. When two black holes spiral into each other and collide, they hit with such violence that they make the fabric of space itself ripple, like a stuck drum. Not the matter inside space. Space. The ripples spread outward at the speed of light, alternately stretching and squeezing everything they pass through. Now picture one of those ripples washing over you. It would not push on your ears like sound. It would stretch your entire body taller and thinner, then squeeze you shorter and wider, then stretch you again, over and over. Every atom you are made of would ride that wave. You would not hear the collision of two black holes with your ears. You would feel it in every single cell at once. For one instant, the universe would be playing you like an instrument. And here's the part that makes scientists' achievement most unbelievable. By the time one of these ripples reaches Earth, after crossing maybe 1 billion light years, it is fantastically faint. When the detectors called LIGO caught their first one, the wave was stretching and squeezing the entire planet by a distance smaller than the width of a single atomic nucleus. We built a machine sensitive enough to feel two black holes collide on the far side of the universe by measuring a wobble thousands of times smaller than an atom. The cosmos was ringing, just barely, and for the first time, we had an ear delicate enough to notice. So if the universe is screaming in waves our ears can never catch, is there any way to actually listen in? It turns out there is, and scientists have been doing it for decades. Spacecraft like Cassini, Juno, and the Voyagers carry instruments that pick up the radio and plasma waves pouring off the planets. On their own, these signals are silent to us, far outside anything a human ear could register. But their patterns rise and fall at rates we can shift down into our hearing range. So scientists take those electromagnetic signals and translate them into sound we can finally play out loud. Nothing is faked. They are turning a real signal we cannot hear into one we can. And what comes out is haunting. Saturn does not hum or beep. The radio emissions tied to its polar auroras, once translated, sound like a ghostly chorus of rising and falling whistles, like something breathing in a cave. Jupiter's worse. As a spacecraft crosses the boundary of its magnetic field, the translated signal lurches from an eerie whistle into a deep oceanic boom, like a storm-tossed sea the size of a planet. These are not sound effects from a movie. They are the actual electromagnetic voices of those worlds, shifted into a key we can hear. And it goes all the way out. Voyager 1, now drifting in interstellar space beyond the planets, still listens to the thin gas between the stars. The signal it sends back, once translated, is a faint, persistent ringing. It is the sound of the space between the stars, and it has been singing that note the entire time, long before anyone was there to translate it. Think about what that recording actually represents. Voyager crossed out of the sun's bubble and into true interstellar space back in 2012, the first human-made object ever to do it. The ringing it hears now is the density of the galaxy itself, the gas left behind by the stars that died before our sun was even born. A spacecraft built in the 1970s, running on less computing power than the phone in your pocket, is still out there in the dark, patiently translating the hum of the galaxy and mailing it home. So here is where it leaves us. We don't live in a silent universe. We live in an ocean of electromagnetic screaming, wrapped in a thin, accidental quiet, because our ears evolved for a planet with air, not for the roar outside. Space is not mute. It's just too vast and too powerful for the fragile biology we listen with. The silence was never out there. The silence is us. So, the next time you stand under a quiet night sky, try to hold both things in your head at once. The peace you feel is real, and it is also a kind of blindness. Every star up there is pouring out signals. The space between them is humming, and all of it is passing straight through you, this very moment, completely unfelt. You were simply never built with the ears to catch it. And here's the thought that lingers. All those screaming signals are crossing almost unimaginable distances to reach us, through a space so empty it is hard to even picture. We just called it an ocean, but how empty is that ocean really? The answer is stranger and lonelier than the silence ever was, and it is on your screen now. Go see it. I'll meet you out there in the dark.